Welcome all back to this last section of the workshop of today. Thank you very much, Cristina, and the space is yours.
Thank you, Esteban. Okay, we will continue with the last part of the workshop. So, yes, we have created a normal random catalog so far with not taking into account any mask. Then now we will include the information of the mask and create a random catalog over the area that we are interested. Then the first part is that you have to open the image and store the data in a 2D array. Well, you don't have to actually open the data image. You have to open the mask image in this case. Then, okay, I will continue here. Everyone can open this as you wish with in your language. Then, in my case, read fits. I will provide the name of the image, which is the mask. It fits. I will read the header mask. And okay, that is the way in which I just read the image. Then I can actually run this. And if I print mask, I should have only 1 or 0 values. Yes. Okay, then this is just an 2D array that is storage the data from the mask image. It's nothing more than that. Okay, so the other thing that I will need here is to read the header of this image and store the values for the size of the image. This should be here in the header, right? Wait a second. Yes. These here are the number of pixels that we have in each axis of the image. Then I will just read the header in IDL and store those two values because we need it to just avoid to generate points farther from the edge of our image. Then I'm gonna just read this here, and I have this done from before to make this more quickly, seeing though you are not following my syntaxes. But basically I'm just defining the X size and the Y size of the image. This is just the function in IDL in which you provide the header of the image that I already read this header here, and you say what is the name of the variable that you want to store. Then I can actually print here those values to check that this is correct. And run this. Yeah, 1575 and 1622. I think that is correct and should match exactly with the ones for this other image. Yes, 1622 and 1526. Those are the same. Great. Then now we are gonna create a cycle 4 from 0 until the number that you choose for your random catalog. Then I said in the instruction 10,000. Maybe I will just put 1,000 to run this more quickly. And within this cycle for, I will generate each individual point over the image. Then it's the same way that we did before. Then I'm gonna copy this here. But in this case, we are going position by position. Then I will store all those positions in 2 different arrays. This is for the right ascension. I'm just creating an empty array with the 1000 positions for declination and right ascension. Okay, then for each step, I will generate a random number within the limits that we defined before, but I will just generate one number each time. And okay, then this should generate the random numbers over the entire image, right? But now we need to check if that is on 1 pixel with value 1 or value 0 in the mask image. Then to do that, first I need to convert from coordinated to pixels, right? And that is something that normally we have functions to do that. Then in case of IDL, there is a function called, I'm gonna copy this here. This is a function called ADXY, in which you go from right ascension declination to pixels, XY in pixels. Then you just provide the header. You have to provide the header of the image. And then you have to provide the coordinates that you are generating. And yeah, I call this 2 to make this distance different to the previous random catalog that I just create. Then you provide the coordinates, and then the function return the positions X and Y corresponding to the pixels on the image. In the case of Python, I made a little bit of research, and you also have a function to do that step. Then you can maybe check this. It's called world to pix. Basically, this is a function that you can use to go from coordinated right ascension to declination to pixels. Okay, then you can make a research to check what are the parameters that you have to provide, but probably you have to provide exactly the same as me, basically the header and the 2 positions. All right. And then you have, well, note that here XY is just, I mean, this function just convert the coordinated using the information in the header, but the function is not taking into account that the size, the total size of your image. Then given that we are generating random points on an area a little bit larger than our image, it could be possible that some of the position will be outside of our image. Then the first step is that I will check if the X and Y values are larger or smaller than the image. And because if this point is outside, I have to generate the point again. Then if X is less if less or equal to the X size, I have not defined X size yet, or did I? Yeah, I did actually. Here I define the X size and Y size. I just took those parameters from the header. I already showed this to you. Then if this X value is less or equal to the size of my image and also greater than 0, greater than 0, and all the same for the y-axis. Then only in that case, I continue. Otherwise, I have to generate the point again. Then to do that, I will just put this, that I decrease the y variable for 1 again, then this will run again. In Python, I guess you have other ways to do this, but that is the way that I choose in my case. And then if we are inside of our image, then we now have to check the mask value in that position. Then if the mask, which is the name of the variable in which I store the data when I read the mask, in the position X and Y, those are pixels, no equal to 1, then that means if the mask, if we are in a pixel in which we have a mask region, then I will again subtract 1 to my variable. Then the cycle will repeat the thing and generate a new point. Note that in my case, here the arrays in IDL start always at 0 position, in position 0. Then given that X and Y are pixels, I actually have to check the position of the pixel -1, just because by definition, the position in IDL start in 0. I'm not sure if in Python those are defined to start at 0 or not. Okay, then that's it. Actually, that is all what you have to do. Yes, I just check if the number is within the edge of the image, and then you have to check the value of the mask in that pixel. Then I'm just keeping in the array the positions that are within the image and with a mask value equal than 1. Okay, then that is the idea. I will give you now some 10 minutes for you to make your own code on this. And after those 10 minutes, I'm gonna show you, I'm gonna plot this and show you how this should looks like. Then yeah, some time for you to make this in your own language. I'm gonna be here again in 10 more minutes. Okay, we have only 5 more minutes, then I'm back to show you what I was expecting that you finish in this workshop. Okay. Okay, if you were successful doing what I showed you just before, I'm gonna show you what I got when I plot this. Just because we don't have so much time, I'm just wrote the code here to plot the random points that we just generated. Yes, and I also, if you check here in the instructions, in point number 10, I suggest you to create a region in DS9 to just check on the same image if we are generating the points in the correct positions. Then for that is very easy. You have to create a text file, and the first 3 lines are given by these comments. This is in the case that you store the positions of the random points in right ascension and declination, then in world coordinates. In the case in which you want to just make the regions in pixels, you just have to change this by and write image instead of FK5. That is the only difference. And here then, instead of provide the coordinates, you have to provide the pixel values and the size of the circle in pixels. Then that is just to double check that we are doing the things right. Okay, then I will run this that we just created. And also I just put here the code to create the file that I just showed you. This is just for DS9. Okay, so I will run this here to create my random points over the image. Okay, done. And then if you plot the sky distribution of the random point, you should get something like this. Then that is exactly what we wanted to obtain. We are not generating points in this area, which was our masked area. Then that is great. And this can, I mean, if you have any mask, if you have some masked in other part of the image, this code should work for any type of shape that you provide in the mask image. Then that is great. And now I'm going to show you how in DS9 you can display the region that you just created. Here you can put in region. You can choose load regions. And you have to provide the file that you just created. This have to have the extension .reg. Then this is the extension for DS9, for regions in DS9. Voila. Okay, then great. All these green points here correspond to the position of the random sources that I just generated. Then you can check that I'm just avoiding this part, which was the masked part, and also I don't have any point outside of the edge of my image. And actually, we can also plot these points over the mask image. Then here, you can also load the regions. And then here you can see clearly that we are just avoiding the regions in which we had a value of 0 in this file. And that's it. Then that is the way in which you can create a random catalog in real observations. Then you can use this random catalog to measure clustering as we did for the previous other workshops. Then that is all for today. And I don't know, I just hope that you could learn how to measure clustering if you were able to follow the workshops from 1 to 5. I think that you got a very nice skill for the future in case you will be involved in clustering projects. You already know how to measure clustering, given any population or any data sample, then that is great. And I will stop here.
Thank you very much, Christina. I don't see any questions right now in the chat, so my guess is that we are finishing this time with the school, particularly with your lectures. I will invite to our last part the participants and the organizers. In this case, the participants is you and Aurora. Welcome all back, Juan Rafael, Aurora, Germán.
Thank you.
Hola. Hello. Thanks.
And finally, we have Professor Hub Rodgering, also online. We are trying to start or finishing, which sound bad, but it is what it is. I would like to read or say some words before we start. So good morning, afternoon, and night, depends where you are right now. We hope that all of you and your families are doing well through these times. After 2 weeks of receiving great lectures by Dr. Keseli and Dr. Garcia Vergara, we reached the end of this 2020 AstrotwinColo School. Today, we have the honor to count with the participation of all our organizers of the school, Professor Hub Rodgering, Dr. Juan Rafael Martinez Galarza, Dr. Germán Chaparro, and myself, Dr. Esteban Silva Villa. On behalf of the organization, we want to thank the 2 teachers of the 8th school, Dr. Keseli and Dr. Garcia Vergara, who dedicated their time, and huge effort to make this school unforgivable. Both topics, high-resolution spectroscopy on exoplanets and large-scale structure of the universe, are 2 topics of great interest in astrophysics, and we hope that all this knowledge will enrich the skills of all our participants. The school had participation of people from Mexico, Peru, Chile, and Colombia mainly, something that we wanted to do since some time ago. From the organization, we think that from here on, all following schools will be broadcasted to all possible platforms in order to reach the largest population possible, maximizing the number of people who will benefit from this. If some of the organizers would like to say something, please open your microphones. You are all welcome.
I guess I will say a few words. Hello, everyone. It's good to see some good familiar friends here. Germán and Lehup, it's always nice to see you and connecting from all over the world. I just want to say a big thank you to Aurora and Christina. This has been really fantastic. I was doing my best to follow during the week for the lectures, but especially following the engaging of people and questions and online viewing, both live and afterwards. And I am very satisfied. The first thing I want to say is you have an important measure of your success is that you are beating the Colombian president in terms of audience for YouTube transmissions at the moment, because he's been getting so boring, and you're doing such a great job that you certainly had more audience. And I think it went extremely well for an online course. You both had prepared very good lectures and good materials, and I really thank you for that. So I really hope that you will consider coming in person for the next edition. I think you will have priority to do so if you want to, because I think it would be really great for you to have also that part of the school, which is you getting in contact with the students there and also knowing a beautiful part of Colombia in Medellin. So I really hope both of you can do that. But thank you very much for filling this gap also in terms of the kinds of topics that students get in Antioquia. I think Hoop can tell you a little bit more about the impact and the influx of Colombian students that they've had in Leiden over the years. And I'm very happy that this can continue. And I really hope to be able to continue. I'm keeping my fingers crossed that in a year's time, the situation will be better in the world. But thank you both for a great job and for joining us this year. And thank you, Hub, for supporting that. Thank you to Esteban and Germán and everyone at the Universidad of Antioquia too for organizing that. Thanks very much. Who wants to be next?
How would like to? You would like to say something?
Say something. Good, good afternoon or good morning or good. Yeah, it was a great pleasure to have Esteban and Juan over now many years. I think, what is it now, 7 or 8 years, Juan?
Well, it started in 2013, so this is the 8th edition. Yeah.
And I think together we did something very special. Basically, very nice astronomy department, and we always have enjoyed this collaboration. And I mean, I think if you look at the lectures over the years, they've been very varied from really theoretical to observational instrumentation, from large-scale structure to exoplanets, and all of this. So I think over the years we've made a big overview, and we're also very helpful. We're very happy that we have been able to welcome a number of master students, a number of PhD students, and some of them then worked with us for a few years, and then they go off to the States, for example, like Juan. So I think this big collaboration is something that over the world with astronomers is that we all really enjoy and value, and we should continue this for a long time. I have not yet visited you guys, but at some stage I really plan to do this because I would really enjoy this. I mean, I was in South America last year, which was great. I mean, I could see the eclipse, and I could see the big observatories. I could see Paranal, and then we took a few weeks off. We even did the famous Machu Picchu trail, but then time was up, and we needed to go back to work. But if I had more time, I would continue traveling up further north and visit it. So thanks again for all the interest, for the warm collaborations, and let's continue this.
Thank you. If you keep following the Inca Trail north, you'll eventually hit Colombia. So please, for your next visit, and I actually do hope that you can join us in person as well. So
if the teachers would like to say something, please open your microphone as well.
I can go. I just wanted to say thank you so much. I had such a good time teaching, and I hope that all the students had a good time learning. And I'm always open for emails if there's more things that you want to ask. So yeah, and also I would love to come next year. It'd be great. My husband's Colombian from Cali, so we were hoping to go together to Medellin. He hasn't been to Medellin either. So yeah, next year maybe. That'd be great.
Yeah, same here. Also would like to thanks for all the organizer to keep this online this year in these weird times. This is a little bit challenge to teach online, and I guess it's a challenge to organize all this stuff online. And I really appreciate the effort that you made, and I will be also very happy to be in Colombia next year, enjoying the summer there, the nice weather. Thank you.
Finally, I will personally want to thank Aurora and Cristina for your time and for sharing your knowledge with us. It was a great honor to meet you, and I hope to see you in person in the near future. I want to emphasize also what Juan Rafael just said. For our next year school, hoping it will be in person, we want to extend our first invitation to Aurora and Cristina, who couldn't visit the country this time. But for the next year, we hope this will be the chance for them to come here and teach in person.
I think one good thing to do, Esteban, would be to create a small feedback form for both the students and the lecturers, so that we can have, you never know if this can this needs to happen online again in the future. So it'd be great to know what their experiences were, what can be improved, what didn't go so well with the online teaching, and both from the students and from them, so we can then share that information with everyone. But other than that, I think it really went very well. It was widely viewed also from other people in other countries, and that's a good thing to have. So thanks very, very, very much, and we will see you in Colombia at some point.
Yeah, I was just mentioning before that we have participation from some countries here in Latin America. I want to put in the screen a special thank you that they sent from India. So we have been broadcasting this, and I didn't know that we have been watching, people have been watching us from India, but I think that all this knowledge will reach many more countries than the Latin American, India, and all possible places that we can reach with this kind of things. So thank you very much, all of you. Thank you very much, Cristina and Aurora, for teaching us. Job, Germán, Juan Rafael, thank you very much for supporting this organization, and I hope to see you all next year.
Thank you so much to the organizers.
Thank you all.
Thank you.
All right, have a great time, and we'll see you soon. See you in Holland next year, hopefully.